All right, good afternoon, mathematicians. Actually, I guess it's good evening, mathematicians. I hope you guys all remembered to turn your clocks forward 1 hour, so that way our precious daylight has been saved. Anyway, in this video, I'm going to go over your Let's Be Rational quiz, Investigations 2 and 3 review. Okay, and that can be found on pages 29 and 30. Now, before I get into the problems here, I just want to remind you that your quiz is going to specifically focus on the skills that we've been practicing in class. So that will be multiplying fractions, whole numbers, and mixed numbers, and also dividing fractions, mixed numbers, and whole numbers. Okay? So that's what our quiz is focusing on this time around. So please keep that in mind. All right, with that, let's go ahead and get started. So question number 1, it says, on a particular map of Denmark, 1 inch represents 15 miles. Now, and then they give us a little key that looks something like this. I want to show you guys what it looks like on an actual map, so let's take a look. Come on, recently added photos. Boom, let's take a look at that. Insert, there we go. Let me expand it here. Boom, okay, I have a map of the US. And if you take a look, can I draw on this? Nope, still moving. Right there. That is exactly what this is. So they tell us that if you were to measure on the map, using like a ruler or something, say you were trying to go from here in California and you want to figure out, well, how far away is Iowa? Or this part of Iowa. So what you would do is you would measure this line using a ruler. Let's say that this is somewhere around, don't check the accuracy on this, okay? But I'm going to say that I took out my ruler and I measured this line, so it is around 6 inches. Okay, now, going back to the problem at hand, so let me delete this, let me get this out of the way. They tell me that 1 inch is equal to 15 miles, right? So thinking of my example, say you're here and you want to get to this point over here, you measure this, and let's say that this right here, I said, what was it, 6 inches, right? And we know that 1 inch is 15 miles, so I'm going to split this. Let's see, 1, 2, 3, nope, come on. There we go. So this little piece is 1 inch, so that's 15 miles. This little piece is 1 inch, so that's 15 miles. And then I keep doing that because I have a total of 6 inches. So that's 1, 2, 3, 4, 5, 6. Perfect. And take a look. What's happening? I feel like a great number sentence that I could write to represent this would be 6 times 15. And so this would be a total of 90 miles. So this is a skill that we're trying to apply to questions 1A and 1B. So let's take a look. Well, what does 2.5 inches on the map represent? And I believe that they want us to write this in miles. So thinking of our process back here, I hope you guys would realize that we do need to multiply here. So let's go ahead and take 2.5. And we're going to multiply it by 15 because every inch on the map is 15 miles in the actual real world. And now we have a lovely multiplication problem. I have a mixed number, so I'm going to go ahead and change this to an improper fraction. So I'm going to do the denominator times the whole number, which is 4. And then I'm going to add the numerator, which is 5. And then I keep my denominator the same. So 2.5 is the same thing as 5 halves. Now with whole numbers, what's nice is that you can just put a 1 underneath them and you have yourself a nifty little fraction. Okay, now I have a lovely multiplication problem where I just multiply the numerators and I multiply the denominators. I do like writing it like this, and shout out to Will for writing it like this because he's the one who showed me. I kind of like the way this looks. Alright, so 5 times 15. Let's do some work over here. So that's 25. 5 times 1 is 5, and then plus 2 is 7. So it looks like I have 75 as my numerator. And then in my denominator, 2 times 1 is 2. And yes, I must simplify. So, how many times does 2 go into 75? Well, 2 goes into 7 3 times. 3 times 2 is 6. So I subtract, I bring down the 5. 2 goes into 15 7 times. So now I have 7 times 2, which is 14. I subtract, and I have a remainder of 1. I'm going to leave the remainder alone. So this 37 becomes the whole number. So 37 miles so far. And the 1 becomes the remainder, or the numerator. And our denominator has not changed at all. So my final answer is 37.5 miles. And there you go. All right. Let's take a look at the next one. What does 3 3/4 inches on the map represent? And I believe they're also wondering, well, what does this represent in miles? So we need to write a number sentence and show our work. So, using the same logic, right? It looks like we're going to take the number of inches and multiply it by 15, because 1 inch means 15 miles. Let's change 3 3/4 into an improper fraction. So, I'm going to take the denominator and multiply it by the whole number. So I get 12. And then I'm going to add the numerator. So I get a total of 15. And I keep my denominator the same. So I have 15/4. And then same thing, 15 over 1. All right, and now let's multiply. 15 times 15 is 225. And then 4 times 1 is 4. Now let's simplify a little bit. There isn't much room on here. I'm sorry about that. Maybe I'll reformat it for next year. Okay, so let's divide, please. 4 goes into 22. I believe that's 5 times, because 5 times 4 is 20. I'm going to subtract. 2 is left over. Bring down the 5. 4 goes into 25 6 times, so 6 times 4 is 24. And I have a remainder of 1. So I'm going to keep that in my back pocket for a second. I have 56 wholes, right? So that's the whole number. And then how many's left over? 1, and the denominator stays the same. So 3 3/4 inches translates to 56.25 miles. Perfect. Okay, there we go. Off to a good start. Let's keep going. Number 2. It says, find each product and show your work. I'm just going to move that up there. Okay. So my best advice is rewrite the problem. There you go. All right, I see an opportunity for cross-canceling here. I notice that I have a 2 in the numerator on one fraction, 2 in the denominator. So what is the biggest number that goes into both of those? Well, 2 goes into 2 one time, and 2 goes into 2 one time. So now I have a new multiplication problem. 1 times 1 straight across the top is 1. 1 times 5 straight across the bottom is 5. And that is my answer. If you did not cross-cancel, that is okay as well. Let's take a look. 1 times 2 is 2. 2 times 5 is 10. And then before you circle your answer, you have to ask yourself, is this simplifiable? Or ask yourself, can this be simplified? And in this case, yes, you can. You divide by 2, and you get the same answer of 1/5. Okay, so always ask yourself, can this be simplified? All right, let's keep going. 3.5 times 4/5. So I need to change 3.5 into an improper fraction. So 3 times 2 is equal to 6. And then 6 plus 1 is equal to 7. So that's 7/2 times 4/5. I see an opportunity to cross-cancel because I see a 2 and I see a 4. Now, ask yourself, well, what is the biggest number that goes into 2 and 4? Or what is the greatest common factor of 2 and 4? Well, hopefully you said 2. So 2 goes into 2 one time, and 2 goes into 4 2 times. There we go. And now I have a simplified multiplication problem. 7 times 2 across the top is 14. 1 times 5 is 5. And I must simplify. 5 goes into 14 2 times. So I'm going to say that's 2 wholes. And then how many is left over? Well, 5 times 2 is 10. 14 minus 10 is 4. So there's 4 fifths left over. So 2 and 4 fifths is my final answer. All right, last one on number 2. 10 times 3 fifths. Now remember, you have to change the 10 into a fraction. So you write 10 over 1. 10 over 1 times 3 fifths. I see an opportunity for cross-canceling. Cross-canceling is nice. Especially if you recognize it, because it's like I said, it's you simplify the problem before you actually do the problem. So it's kind of nice. All right, so what is the biggest number? What is the greatest common factor of 10 and 5? Well, 5 goes into both of those. So 5 goes into 5 one time, and then 5 goes into 10 2 times. Now I multiply straight across, so that's 6 over 1, but I'm just going to rewrite it as 6. And there we go. All right, moving on to problem number 3. Let's take a look. It says to find each quotient and to show my work. So if you guys are ever at all confused as to what it looks like to show your work, hopefully you've been paying attention, because what I've been writing, is exactly what you guys should be doing on your page. You should be showing me your thought processes, okay? Because I cannot read your mind, I promise. All right, so question 3a. 2/3 divided by 1/2. So, if you guys like your KFC, of course that means something else in real life, but in math class we're going to say keep, flip, and change. You're going to keep the first fraction, because keep is the first word. So 2/3, I'm just going to leave the same. You're going to flip the second fraction, because flip is the second word. So I'm going to take the reciprocal of 1/2, which just means I flip the numbers, so now it's 2 over 1. Lastly, I change from division to multiplication, and then I solve. So 2 times 2 across the top, that is 4. 3 times 1 is 3, and I have to simplify, so this simplifies to 1 and 1/3. There we go. Let's keep going. Change 2.5 into an improper fraction. Please do that with all mixed numbers before you do any math to them. Okay? Before you multiply or divide. Okay? So let's take a look. So 2 times 2 is 4. 4 plus 1 is 5. So I have 5 halves divided by 4 fifths. Now let's do our keep, flip, change. So keep the first fraction, 5 halves. I flip the second one, so now I have 5 fourths, and I change from multiplication or division to multiplication. Now, be very careful, folks, okay? Because I know at the beginning of this problem, it looks like you have some opportunities for cross-canceling. Right? Well, let's solve this problem first to see if we end up with the same answer, okay? So, let's just solve this first. So I have 25 across the top, and then 2 times 4 is 8, and this simplifies to 3 and 1/5. Okay, now let's try this. I'll do this in red. Let's see what happens if I cross-cancel first. So those become 1s, and then that becomes a 1, that becomes a 2. All right, so now I have 1 over 1, then I have 1/2, then I have 1/2. We do not get the same answer. So please, with division, do your key flip change first and then look for opportunities to cross cancel. Okay, you have to do your KFC first before you try to cross cancel. All right, last one for number 3. So 12 divided by 2/5, change 12 into a fraction, so it's 12 over 1. And then then we write the rest of the problem. There we go. And we're going to do a little KFC, some keep, flip, change. So I keep the first fraction, I take the reciprocal, or I flip the second one, and then I change from division to multiplication. I have an opportunity to cross-cancel. That's nice. The greatest common factor of 2 and 12 is 2. So 2 goes into 2 one time. 2 goes into 12 6 times. And there we go. 6 times 5 is 30. 1 times 1 is 1. My final answer is going to be 30. And there we go. All right, let's keep going. Bob is making treat bags for his daughter's birthday. He decided to use the recipe below for each bag. He needs to make 6 bags, so each friend can have one. And he wants to make half a bag for his 2-year-old to have. Oh, how nice. Okay, how much of each ingredient will he need to make the 6.5 bags? Write number sentences to support your answer. So here's the recipe. I apologize for how this is formatted. I'm not sure why these... I feel like question B should be a problem by itself. But anyway, so here's the recipe. It takes 2/3 cups of peanuts, half a cup of pretzels, 3/5 cup of raisins, and 1 cup of popcorn. And we need to make a total of 6.5 bags. So the way that I would go about solving this is I would take each part of the recipe, right? And then I would multiply it by 6.5 because that's how many bags I need to make. So for example, I'm going to do 2/3 and I'm going to multiply it by 6.5. First, let's change 6.5 into an improper fraction, just so I don't have to rewrite this all the time. So 6 times 2 is 12, 12 plus 1 is 13, so 6.5 is the same thing as 13 halves, okay? So now I can multiply all of these parts by 13 halves. So I take 2/3, I multiply that, I multiply that by 13 halves. I see an opportunity for cross-canceling. There we go. My 2's. 2 goes into 2 one time, so they change into 1's. And now I have something like this, 13 over 3. And yes, I have to change that back into an improper, a mixed number. So 3 goes into 13 4 times, because 4 times 3 is 12. And then how many's left over? 1. So I have 4 1/3 peanuts, cups of peanuts. Boom, first part done. Okay, next part. I need a half cup of pretzels for 1 bag. But I need to make 6.5 bags, so I'm going to multiply that by 13 halves. So I get something like this. I don't have an opportunity for cross-canceling here, so 1 times 13 is 13. 2 times 2 is 4, and I need to simplify this into a mixed number. 4 goes into 13 3 times, because 4 times 3 is 12. 13 minus 12 is 1, so I'm left over with 1/4. There we go. So 3 1/4 cup of pretzels. And there we go. All right. 3/5 cup of raisins is next. So I'm going to do the same thing. I'm going to take that 3/5 cup and I'm going to multiply it by 13 halves. Still no opportunity for cross-canceling, but that's okay. So 3 times 13 is 39. 5 times 2 is 10. And I need to simplify this. 10 goes into 39 almost 4 times, but it's only 3 times. So we have 3 wholes. And then how many's left over? 9/10. And this is raisins. So 3 9/10 cups of raisins. And then the last piece of the puzzle here is 1 cup of popcorn. 1 I can rewrite 1/1, and I multiply that by 13 halves, which is just 13 halves, which is just 6.5 cups of popcorn. And there we go. Big shout out to Ava, who actually did all of this. She did all this, figured out all of the different recipe components, and then added them together. But the question only asked us to find the components. How much of each component do we need? Not what is the total amount here. So shout out to Ava for doing all of that hard work. All right, let's keep going on. We're almost done, folks. So I had 3/4 of a bag of Halloween candy, and some friends came over and ate half of it. How much candy did they eat? Use a drawing and a number sentence to support your answer. So let's take a look. This reminds me of my brownie pan problems. Because I have 2 fractions, right? And they're using the word of quite a bit. And if you'll notice, or if you remember back to our brownie pans, the people were trying to purchase fractions of brownie pans, right? So it's always a fraction of another fraction. So let's take a look. I had 3/4 of a bag of Halloween candy. So I'm going to split I'm going to say that this box is my bag. So I'm going to split this into fourths. Just like that, okay? And then I'm going to shade in how much I actually have. So there's 1/4, there's 2/4, and there's 3/4. So my bag is 3/4 full. Now my friends have some other plans for my candy, and they're going to eat half of it. So I'm going to split my bag in half going the other way here, just like that. And I'm going to shade in half of the entire square. So there we go. Now I'm going to count how many sections do I have? So 1, 2, 3, 4, 5, 6, 7, 8. And then I need to ask myself, well, where do my two colors overlap? And in this case, I have 3 sections where the colors overlap. And 3 out of how many? Well, there's 3 out of 8. So if you were to write a number sentence, you would say, well, if you had 3/4 and you took half of it, well, what operation's happening here? Well, I hope you guys remember that of is a big indicator to use multiplication. Because when you use the standard process, so right, multiplying straight across the top, straight across the bottom, hey, you get the same answer. Okay, let's take a look at question C. I had half a bag of Halloween candy, and some friends came over and ate 3/4 of it. How much candy did they eat? So, if I'm writing a number sentence, my friends ate 3/4 of 1/2. So of is the big keyword here. So it looks like I'm going to take 1/2 and I'm going to multiply it by 3/4. So it looks like they ate 3/8 of a bag of candy. Interesting. Explain how problem A and B above are similar. Explain how they are different. So if you notice the first time, you started with 3/4 of a bag, and then your friends ate half of it. But then the second time, you started with half a bag of candy, and then your friends ate 3/4 of it. So I guess what we could say, the problems are different because the order of the numbers is different, right? We did 1/2 times 3/4 versus 3/4 times 1/2, so the order of the problems are different. Now, you guys might notice other things that are different, but this is the one thing that's sticking out to me. Okay, so the problems are different because the order of the order of the problems, the order of the numbers are different. So we have 1/2 times 3/4 versus 3/4 times 1/2. Okay, how are the problems similar? Well, the numbers are the same, right? We're still working with 1/2, we're still working with 3/4. So the problems are similar. Because we're multiplying the same numbers. Okay, and we're moving on. The last 2 questions, awesome. Okay, here we go. Sarah is making pudding. Pudding sounds good, sorry. She has 4.5 cups of milk. If she uses 2/3 of a cup of milk to make 1 serving of pudding, how many servings can she make? So, this goes back to our problem with the pizzas, right? Where you guys had a bunch of blocks. So hold on, let me redo this. You guys had a rectangle that looks something like this. Let me see if this works. Yay! And then, right, it was split into 9 blocks of cheese, right, so on and so forth. So yes, we had a problem like that. And the number sentences we wrote were actually division problems. So we are trying to take this total amount of milk and we're trying to split it into groups of 2/3. And if you think about how division works, it's exactly what we're doing here, right? We're trying to see how many times a number goes into another number. In this case, we're trying to figure out how many times does 2/3 go into 4.5. So I'm going to write the number sentence, 4.5 divided by 2/3, and I have myself a division problem. Okay, so let's change 4.5 into a mixed number. 2 times 4 is 8, plus 1 is 9, so that's 9 halves divided by 2/3. I keep the first fraction, so I'm going to write 9 halves. I flip the second fraction, so now I have 3 halves, and then I change this to multiplication. So 9 times 3 is 27, 2 times 2 is 4, and I must simplify here. So 27 divided by 4, ooh, that's almost 7 times, but because 7 times 4 is 28, but we're 1/4 short. So we can go in 6 times, and 6 times 4 is 24, 27 minus 24, that means there's 3/4 left over. So she can make 6 3/4 servings of pudding. Okay, now please make sure you guys include your units, and by units I mean the meaning of your numbers. In this case, it's servings, sometimes it's inches, sometimes it's feet, sometimes it's the number of watermelons, so on and so forth, okay? I want you guys to make sense of these numbers. What do these numbers represent? And writing your units helps you do that. Okay, so Julie, Sarah's friend, I'm assuming, is also making pudding. She started with 8 1/4 cups of milk. She has used half of her milk. How many cups of milk has she used so far? So if I use my rectangle example from before, I'm going to say that this entire thing represents 8 1/4 cups. However, Julie has used half of it. Whoa. Julie has used half of her milk supply. So we want to figure out, well, how many cups is this section right here? Well, how would I do that? Again, I see the keyword of. And of in word problems usually means to simplify. If you are if you're finding a number of another number, that signifies to multiply. So to help me find this purple section here, I need to find, well, what is it? 1/2 of 8 1/4. So I'm going to use this number sentence to help me solve this. So I need to change 8 1/4 into an improper fraction. So 4 times 8 is 32. 32 plus 1 is 33. And I have 33/4. And I'm taking half of it. So let's multiply straight across the top. That's 33 over 8. I have to change this back into a mixed fraction, or a mixed number. And 8 goes into 33 4 times, because 8 times 4 is 32. And then if I subtract 33 minus 32, that's 1 left over. And my denominator stays the same. So she has used, so far, 4 1/8 cup of milk. And there you have it. All right, I hope you guys found this video useful. I wish you the best of luck on your quiz tomorrow and on Tuesday. And happy studying, folks. I'll see you in the next lesson.